problem number 6, we have the square root of 3n plus 1 minus the square root of n plus 1 equals to 2. Remember, your first objective is to isolate one of the radicals, all right? So isolate the radical sign. But since we have 2, you can just focus on isolating 1. Usually I isolate the radical that looks the scariest. So in this problem, the square root of 3n plus 1 looks more intimidating than that square root of n plus 1. So I'm going to add the square root of n plus 1 to both sides. By doing that, that cancels out the radicals there, and I'll bring down the square root of 3n plus 1, which equals to the square root of n plus 1 plus 2. Then I'll be squaring both sides. So on the left side, I have the square root of 3n plus 1 squared, which equals to the square root of n plus 1 plus 2 squared. On the left side, the square root and the square will cancel out to leave me with 3n plus 1. However, on the right side, since I have a binomial now that's being raised to the second power, I'll need to expand that and multiply it out. So this is going to be the quantity of the square root of n plus 1 plus 2 times the square root of n plus 1 plus 2, just like that. From here, ladies and gentlemen, we'll go ahead and full all this out here. We're going to multiply it all out. I'll be bringing down this 3n plus 1, which equals to the square root of n plus 1 times the square root of n plus 1 is just n plus 1. Then the square root of n plus 1 times 2 gives me a positive 2 times the square root of n plus 1. 2 times the square root of n plus 1 is another positive 2 times the square root of n plus 1. Then finally 2 times 2 gives me 4. So this is what I have thus far. Then on the right side, I'll be combining my like terms. So I'm bringing down this 3n plus 1. This now equals 2. I have 4 times the square root of n plus 1, combining these two terms together. Then I'll have a positive n, and 1 plus 4 is 5. From here, I'm going to be subtracting n to both sides, as well as subtracting 5 to both sides. All right. Once I have this in play, I'll have 2n minus 4 equals to 4 times the square root of n plus 1. The n's and the 5's will cancel out. From there, I'm noticing that all three terms can all be divided by 2, so I would prefer to have this simplified as possible. So I'm going to divide every single term here by 2 to end up with n minus 2 equals to 2 times the square root of n plus 1. All right, that's what I have thus far, ladies and gentlemen. Let's go ahead and take this to another page here. All right, so let's go ahead and copy that. All right, and now let's continue the problem here. Okay, now that I have the n minus 2 equals to 2 times the square root of n plus 1, notice that I still have another radical in play. Ideally, you would want to get the radical by itself, but notice if I divide everything by 2, I would end up with fractions. I don't want to deal with fractions. So instead, I'm just going to square both sides the way it is. So on the left side, I have n minus 2 squared equals to the quantity of 2 times the square root of n plus 1 squared. On the left side, I'll have to expand that, so it'll be n minus 2 times n minus 2. And on the right side, you would have 2 squared, which is 4, and then squaring your radical just ends up bringing the radicand out. So this will be times n plus 1. We'll go ahead and multiply everything out. So n times n is n squared. N times negative 2 is negative 2n. Negative 2 times n is negative 2n. And finally, negative 2 times negative 2 gives me a positive 4. On the right side, I got my arrows popping. So I'm going to end up multiplying 4 times n to give me 4n plus 4 times 1 is 4. From here, I'll be combining my middle terms on the left side. So I have n squared minus 4n plus 4 equals to 4n plus 4. Then I'll be setting everything equal to 0. So I'll subtract 4n to both sides. I'll also subtract 4 to both sides. Doing this, ladies and gentlemen, everything on the right side cancels out. I bring down n squared minus 8n. My 4's cancel out, so this equals to 0 here. Next, I'll factor out an n. So I have n times n minus 8 equals to 0, and then I'll set each one of these factors equal to 0. So you have n equals to 0 as well as n minus 8 equals to 0, which means that n equals to 8 as a possibility. Remember, we'll be testing these values back in the original equation. For problem number 6, testing 0, we'll have 3 times 0, which is 0, and then 0 plus 1 is 1. The square root of 1 is 1, so that value is 1 right here. I'll go ahead and write it there. Then minus, plugging in 0 here, this is going to be 0 plus 1 is 1, so the square root of 1 is 1. So 1 minus 1, ladies and gentlemen, equals 0, not 2, which means that 0 is an extraneous solution, so that won't work. All right. Next, let's try plugging in 8. Plugging in 8, we have 3 times 8, which is 24. 24 plus 1 is 25. The square root of 25 is 5. So I'll be writing 5 right here. Then I have 8 plus 1, which is 9. The square root of 9 is 3. So 5 minus 3 will give me 2, which means that our only solution to this problem is 8. So that means, ladies and gentlemen, that 0 is extraneous, and our only solution to the problem is 8, and that's our answer.